Today we're going to talk a little bit about pointers and how C++ uses pointers. Something we did not have whenever you were learning Java in the 1400 class. Java had references and C++ has pointers. Yeah, there's a bunch of stuff we're going to talk about. Okay, so here's kind of a reverse. I'm going to go back for a little bit and we're going to compare this to what you know. Variables is what you know. We know int num equals 10. Well, the name of the variable is num. Int, that's the type of information it's storing, and 10, that's the content or value or whatever you want to call it. Now, whenever you put a store of data into a variable, it actually has to store that, and it stores it someplace over in memory. We don't care about this memory location. We know that if we just use this name num, it will give us the 10 that we're looking for. Now that int portion allocates how many bytes of data it's going to store. Int stores 4 bytes of data, but we'll call it 2 for our example. And so 10, it's taken up this much information. A double is going to have more bytes of information because it also stores decimal places and it stores bigger numbers. So double has more bytes. Now we can use the address of operator. That's the ampersand. It's also, remember, when you're passing by address, you pass using that ampersand. Same concept. So what the address of operator does is it gives us where that address is. So here, let's kind of give you an example. I have int num equals 10. So this is this place in memory right here, and double num2 equals 15.7. So that's going to be coming to this place in memory. If I were to do a cout statement for ampersand num, it would give me this value right here, the first place of the memory location where it's stored. If I were to do a cout statement for num2, it would give me this value right here. Oh, there it is. I even have the animation for it. Okay, now pointers are variables, but they're variables that have the value, the content is a memory address. It points to the first byte in memory wherever your variable is stored. And a pointer is defined by using the asterisk or the little star sign. So this is a pointer, and I pointer, and double D pointer. Those are both pointers. They're not pointing anywhere yet because we haven't set them equal to anything. But we know they're pointers because they have the cute little star before them. They're going to eventually point to an int. This one is going to point to an int value. This one's going to point to a double value, but we know they're pointers. Let's show you how they work. Now suppose I have two variables. These aren't pointers because there's no stars. I have num to 10 and num2 to 15.7. Here they are stored in memory. Now, if I declare two pointers, I've got I pointer and D pointer. They're not pointing anywhere because I haven't actually set them equal to anything yet. But if I do, here in the next, dang it, move out of the way, cute little window. You can't see. At the very bottom, I can't put my mouse down there, otherwise that thing will come back and you can't see. It's setting I pointer equal to the address of num1 and D pointer equal to the address of num2. So this pointer is pointing, it has the value of this as its actual content, and D pointer has the value of this. So if I were to do a cout statement for I pointer, I would get W001, which is actually not a valid memory address, but for the example it works. Now there's two purposes of this little asterisk sign. Number one, you can declare a pointer, which we've already seen. You can say int star, whatever you want to name it, and we know it's a pointer because of that star. But it's also a dereferencing. So for example, if I do a cout statement for my two pointers, just how the same information I have set up here, it's going to print out the address location, this and this. If I add that asterisk in, so I'm doing a cout statement for the pointer, but I have that star in front of it, it's called the dereferencing operator in this particular situation, and what it does is it prints out that the value that's stored wherever the pointer is stored. So it would actually print out this 10 and the 15.7. Okay, variables and pointers. Okay, so they both have names. Here's our original slide again, but I want to compare the two. So they both have names. There's num is the name and PTR is the name. They both have an address or memory location. So a pointer actually has a memory location. Here's the difference between a pointer and a variable. The variable stores the value, and the pointer, as its value, stores the memory location. Weird. Yeah, pointers are weird. They're kind of fun though. So if I do a cout statement for ampersand PTR, that would give me my 123. All right, now one more thing with pointers is we have this const keyword. Now the const keyword on variables was so that you couldn't change the value of the variable. But it means a little different when you have a const for your pointer. And you could put this const keyword in different places to mean different things. So let's show you for the example. The first, const int PTR. This means it's a constant int. It's not going to change anything. Int star const PTR, that's a constant memory location even though the value in the memory location may change. And this means both. It's a const value and a constant memory location. Yeah, this is just kind of superfluous information, so you know that you're going to see that const keyword in lots of places, and that's what it means. Okay, so hold on the next video and we'll talk a little bit more about allocating memory.